Hello viewers, welcome to the lecture. In this presentation, I will discuss about the basic types of motors used in electric vehicles, the battery options commonly used in EVs, and the working principle of important motors such as brushless DC motor, permanent magnet DC motor, permanent magnet synchronous motor. This is important because the motor and battery together form the heart of an electric vehicle. Welcome to the lecture once again. Types of motors. Basic classification. Let us begin the basic classification of motors used in electric vehicles. Broadly, motors can be arranged as hub-type motors, mid-drive motors. Hub-type motors are mounted directly inside the wheel and are common in electric scooters, electric bikes because of their simple construction. Mid-drive motors are placed near the drivetrain, giving better torque transfer and improved vehicle balance. Types of motors: BLDC, PMDC, PMSR. PMSM. Here we see three important motor types used in EV related applications. BLDC stands for brushless direct current motor. This brushless direct current motor is widely preferred in modern electric vehicles because of its efficiency and low maintenance. PMDC. PMDC means permanent magnet direct current motor, which is simpler but less suitable for high performance applications. PMSM, that is permanent magnet synchronous motor, which is highly efficient and is commonly used in advanced electric vehicles. Types of batteries. Now let us look at the battery types. The slide shows lithium-ion batteries and lead-acid batteries. Lithium-ion batteries are the most common popular choice in modern electric vehicles because they offer high energy density, lighter weight, and better charging performance. Lead-acid batteries are cheaper and simpler, but they are heavier and have very low efficiency. So they are mainly used in low speed or low cost electric vehicles, or even it is used as an auxiliary power source. Let us see the working of a BLDC motor. A BLDC motor mainly has two parts, the stator and the rotor. The stator contains the stationary coils which create a rotating magnetic field, while the rotor contains magnets that respond to this field. Hall sensor detects the position of the rotor and the controller uses this information to shift the current electronically. Because of this controlled magnetic attraction and repulsion, the rotor keeps the rotating continuously. BLDC motors components and images you can see in this slide. This visually shows the internal parts of a BLDC motor such as stator, rotor, shaft, winding and magnetic pole sensor. It also highlights the Hall sensor arrangement used for detecting rotor position. These sensors are essential for electronic commutation because they help the controller to decide when to energize the stator windings. This is what makes BLDC motors precise and smooth for its operations. BLDC motor in electric vehicles. One of the biggest advantages of BLDC motor is that it has no brushes or commutator. So this reduces the friction and wear and maintenance. In electric vehicles, the BLDC motor powers the drivetrain and gives good control over speed and torque based on the driver's input. Because of its higher efficiency and reliability, and smooth performance under different loads. BLDC motors are widely used in electric two-wheelers and small electric vehicles. PMDC motor in EVs design and operation. Next is the PMDC motor or permanent magnet direct current motor. This motor, the stator produces magnetic field and the rotor contains permanent magnet. When the current flows, the interaction between the stator and the rotor field causes rotation. Compared to BLDC motors, PMDC motors are simpler in construction, but they depend on brushes and a commutator for several reversal for current reversal, which makes them mechanically less advanced. PMDC motors in EVs. Brushes maintain electrical contact and the commutator changes the current in direction in the rotor coils. PMDC motors are used in small toys, tools and low power applications because of their simple and low cost design. However, brush wear, higher maintenance and limited speed range, also less precise control, makes them less suitable for the EV applications when compared with BLDC motors. Now let us discuss the PMSM motor, which stands for permanent magnet synchronous motor. This motor has permanent magnets on the rotor and stator windings that create a rotating magnetic field. The rotor aligns with stator field and rotates as synchronous speed. Sensors provide rotation rotor position and feedback, and the controller adjusts the current frequency accordingly. This enables highly accurate and efficient motor control. PMSM motors are known for efficient operation because the permanent magnets provide a strong magnetic field with minimal energy loss. They offer precise speed and torque control, which is very useful in high performance EVs. Since the controller continuously responds to the driver's input, the vehicle gets smooth propulsion and better efficiency. For this reason, the PMSM motors are commonly used in premium electric cars and advanced EV systems.